Welcome back to this next video in which we are discussing influenza. So, in the previous video, I justified for you where all of these symptoms that I listed at the start of the video actually come from in influenza. I'd just like to make a few more comments about symptoms and then we'll talk about the major complication that can arise with influenza, which is pneumonia. Okay, so one of the comments that I'd like to make is concerning this cough. Now remember, we said that the cough is to try and clear the airways, to try and clear the bronchi, the trachea, and the larynx of the garbage, the gunk that is built up there, the exudate, mucus, and the dead cells. And by the way, there is a special name. Here's an extra comment that I didn't know I was about to make, but there is a special name for this mixture of exudate, mucus, and cells. This is what we call phlegm or sputum. So phlegm is one name for this mixture, this gunky mixture that we're coughing up and sneezing up. The other name is sputum. So that's the words that we use for this mixture of exudate, a bit of mucus, and these dead cells, white blood cells, and the dying epithelial cells. Now, that wasn't the actual comment that I wanted to make, that was just another little thing that I realised I wanted to say. I want to make a comment about the cough that you get generally with flu. So we've justified why you get a cough, it's to try and clear the phlegm from the airways. However, in influenza, you get a very characteristic cough, which is described as a barking cough. And the reason it's described as a barking cough is that it sounds like a bark. Whenever you make the cough, it sounds like a seal barking is the sound that it's generally compared to. And this is characteristic, this is the characteristic cough that people get when they have both inflammation of the larynx and inflammation of the trachea. So laryngitis and tracheitis, whenever you get those together, which we've seen you usually do get in flu, you characteristically get this barking cough, this cough that has a barking nature to it. And whenever you make the cough, you'll generally get pain, so it's painful barking cough. So I'll just add that in here. So the barking cough will cause pain. And of course the reason for that is that when these airways are inflamed, we know that there's prostaglandin E2 being produced. That will be stimulating the nociceptors to try and make them fire action potentials. When you cough, that movement that's produced will also be stimulating the nociceptors a little bit. And normally when you cough, that stimulation that the movement produces on the nociceptive neurons will not be big enough to actually make them fire, and therefore usually coughing is not painful. You won't get pain in your voice box and your airway normally when you cough, because the nociceptors aren't receiving enough stimulation to make them fire action potentials just with that movement. But when you've got the prostaglandin E2 and the movement combined, that then is enough to make them fire action potentials, and therefore you experience pain when you cough, a pain in the throat, and also a pain further down than the throat, which is the sort of tracheal pain. It's only a minor pain, but it's still not a particularly nice sensation at all. Okay, so that's one of the comments that I wanted to make about the symptoms that we've been discussing. The other comment I wanted to make is about the timing of these symptoms. So I want to tell you things like what is the normal incubation period for flu, i.e. the time between actually contracting the infection and starting to get symptoms, and how long do the symptoms usually last for. So let's begin. The incubation period for flu, which means the time between sustaining the infection and actually getting symptoms, is usually quite short. It's usually between 1 and 2 days. So the person will initially get infected, and then 1 or 2 days later, maybe even less time than that, they'll start to develop symptoms. And normally, of course, the symptoms will begin with the nasal symptoms, because that's usually effective first. Then it will spread back and you'll get the pharynx symptoms, so the sore throat. Then you'll get the voice symptoms, so sore throat again and a hoarse voice. Then you'll start getting the cough as it spreads down the airways, and this will become a barking cough once you've got laryngitis and tracheitis together. And you may well then get shortness of breath at the sort of end of the disease, before the adaptive immune system actually kicks in, once it's got down to these airways. Meanwhile, as we're progressing down the local symptoms, that's very easy to understand how they progress. It starts with up at the nasal and then works its way down as the disease progresses. And this will progress over a few days. It will spread down the respiratory tract and you'll get these other local symptoms over a few days. Meanwhile, as they're developing, as you get more and more inflammation occurring in the respiratory system, as that builds up, of course, you'll get more TNF-alpha, more interleukin-1 and more interleukin-6 in the blood, and therefore the systemic symptoms will come on, and they'll get worse and worse the more tissue is actually inflamed. And usually the symptoms of influenza last for about a week. You'll be taken out of action for a week by the systemic symptoms, particularly the tiredness, and all you'll want to do is lie in bed for a week. And then the week following that, the systemic symptoms will start to relieve, the adaptive immune system will be kicking in and starting to remove the virus completely from the respiratory system, but some of the local symptoms will remain. You'll be able to go back to work because you'll feel better, but some of the local symptoms may well remain, for instance, the cough and the sneeze, because it's going to still take quite a while to clear all this gunk from the nasal cavity and the airways, and those two things are necessary for doing that. So you may well have a cough for up to another week after. So overall, just to write a little bit of this down, where should I put it? A little timeline. We'll squeeze it in over here, and it hasn't copied perfectly when I went from the previous video to this one, so you'll notice that we've lost a little bit of our work here, but it's quite convenient because it gives us this little bit of space where I can now put a timeline in. So, first little period is 1 to 2 days, and this is the incubation period. So, actually I'll put a big dramatic red dot at the start. So here, on our timeline is when you get infected, when you first breathe in the influenza virus, as you come into contact with someone else who's got influenza and you breathe it in. So you get infected at the red dot, then you've got that 1 to 2 day period where you don't have symptoms yet, but the virus is starting to take hold of your respiratory epithelium. So this is the incubation period, and it might be even shorter than 1 day. It might be a few hours potentially. And that period is where the virus has gone into cells, it's exploiting the cells, but the cells have not yet died. Remember, you're not going to get any inflammation until the cells have started to die, really. That's when the major inflammation is going to start, and therefore symptoms will start. It's the inflammation that causes symptoms rather than the actual infection. So that's what's happening in the incubation period. Then the next period is the full-on disease, so we'll have this in yellow here. So in yellow here, this is where gradually you're getting more and more of the local symptoms, and the systemic symptoms will also build up as you're getting more and more inflammation. So this is usually around 7 days. And then usually by the end of those 7 days, the adaptive immune system will kick in. So after a few days, the adaptive immune system will kick in. Inflammation, remember, starts here. So it's quite nice, actually, this little timeline. This is where inflammation starts kicking in, and that's why you start getting the symptoms. So innate immune system starts here. Later on, you'll get the adaptive immune system kicking in, and it will clear the infection out. And by the end of the 7 days, the influenza virus has gone. It's been annihilated. However, you will still have some symptoms for the next week after this, which I'll now put here in white. So another 7 days where you'll have some symptoms, but not all of them. So the two major ones that remain is the cough. That's the absolute major one that remains. And you may also have a runny nose and be sneezing. So a few of the nasal symptoms may remain as well. But the virus has pretty much gone at this point. It has been annihilated by the adaptive immune system, and all that we're now trying to do is clear up the remaining gunk, replace our lost respiratory epithelial cells. Of course, the basal cells will be dividing and dividing and dividing to try and replace the lost respiratory epithelial cells, and we're trying to clear away the ones that have died and clear away all of the white blood cells and try to return to a bit of normality. And in that period, you'll still be coughing and sneezing, but you won't be contagious at this point because the virus has been eliminated by the adaptive immune system, which kicked in here. And I might just mark on here. After, let's say, should we go for 3 days for the adaptive immune system to kick in? This is where we've got the adaptive immune response. So in green here, this is the adaptive immune response kicking in and destroying the virus, whereas at the start there, that's the innate immune response coming on. So for a few days, the innate immune response is trying to deal with it on its own, and it doesn't, is the reality. It slows it down, certainly, but it doesn't conquer it. You need the adaptive immune response, and we will come on and discuss the adaptive immune response, therefore, because it's so important. So, there's a timeline of how the symptoms of this disease are actually going to progress. So, enough of the symptoms then. Let's now complete up what I've got to talk about the pathogenesis, which is with pneumonia, and then just a little bit of a comment about the cold, and then we'll go on to the discussion of the adaptive immune response that's going to annihilate influenza, and this will be a good revision of your immunology. Okay, so let's put a scary title because we're about to discuss a very serious illness. So, big scary red is here. We're going to discuss pneumonia, which, as I say, is the serious complication that can occur following influenza. Now, if you are young and healthy, this should not happen. You will get the symptoms that I have described, and the disease will progress just as I've described. The adaptive immune system, which we haven't studied yet, but we will kick in and annihilate it. And it's not pleasant. You'll have 7 days where you are taken out and you can't do anything, but you get better, and you do not get pneumonia. However, in people who are weak, people who have weak immune systems, maybe because they've got AIDS, or because they are taking immunosuppressants, or because they're on anti-cancer chemotherapy, or because they're very, very old, and as I've said previously, the adaptive immune response and also the innate immune response become weaker as you get older. In these people, you can get pneumonia. So, let's remember what pneumonia is. Pneumonia is inflammation in the lung parenchyma, so in the alveolar spaces, that is caused by an infective cause. Remember, an infective cause, rather. The pneumonitis word means inflammation in the lung parenchyma that's caused by something else. So, for instance, an autoimmune response, or maybe a hypersensitivity response, or some disease that we don't really know what the cause is, such as sarcoidosis, which is an inflammatory response that can occur in the lung parenchyma, and we don't really know what the cause is, but we don't think it's a bug. Okay, that would be described as a pneumonitis, whereas pneumonia is inflammation in the lung parenchyma caused by infection. So, how can influenza cause this? Well, actually, before we go on to how influenza can cause this, let's just go over the major symptoms of pneumonia. So there are two that I want to put down here, the two major symptoms of pneumonia. The first one, the most important one, the one that's always there nearly, is shortness of breath. And this is extreme shortness of breath. This is, you get into a complete panic. You can't breathe properly, short of breath. You are sitting in your chair panting for breath, and still you do not feel satisfied. You feel as though if you don't get more air in, you're going to die. And people get into real panics and call, of course, for ambulances. And many people with pneumonia end up being hospitalized for this reason. And it's the shortness of breath that scares people and makes them call for help. So shortness of breath is a major symptom of pneumonia. And why do you get shortness of breath? Well, let's go to our picture of the alveolar epithelium. We'll actually use a bit of our prerequisite knowledge that we went over. So here is my picture of the alveolar epithelium, drawn hours ago now, in the video sense. Days ago for me in reality. Okay, so when you get inflammation in the alveoli, what's going to happen is exactly as we previously described. You'll get an exudate forming and you'll get white blood cells. Let's ignore the white blood cells. Think about the exudate. You're going to get fluid filling the alveolar space. Now, if fluid fills the alveolar spaces, air cannot fill those alveolar spaces, and basically all the patch of lung parenchyma that is inflamed in pneumonia is made utterly useless for gas exchange. So potentially huge chunks of your lung become utterly useless in pneumonia, is what happens, and it's because of the inflammatory exudate in the alveolar space, which is not air and therefore blocks gas exchange from occurring in that portion. So that's the reason that you become short of breath. It's because of the exudate. So I'll just put that as the reason here. So the inflammatory exudate means that that portion of lung becomes useless as far as gas exchange is concerned, and therefore oxygen levels in your blood go down, carbon dioxide levels go up, and that alarms receptors all over the cardiovascular system that have a job of detecting what the oxygen level and what the carbon dioxide level is in the blood. They send signals up to the brain saying, help, there is a big problem with the respiratory system, you need to breathe faster, you need to breathe harder, take in bigger breaths, and it causes the panic sensation. So that's the major symptom of pneumonia. So, let's now talk about the other symptom of pneumonia. There is a second symptom of pneumonia. Now, this one does not always occur with pneumonia. Many people can have pneumonia and not have this symptom, whereas shortness of breath is always there, and that's the reason that people come into hospital, because they're panicked, because they can't breathe properly. The other major symptom of pneumonia is pleuritic chest pain. So, what does pleuritic mean? Pleuritic means that it occurs when you breathe, so pain when you breathe in and out. Now, the lungs are like the brain, they are not innervated by pain nerves. So, having inflammation actually in the lung parenchyma is not actually a problem. It does not cause pain in the lungs. However, just like in the brain, the lungs are surrounded by a connective tissue layer, which is known as the pleura. In fact, two connective tissue layers, the visceral and parietal pleura. So I'll just remind you of this. So, if I just draw a basic picture of a lung here, so this is the right lung here in green, and of course, here is the right bronchus coming in. Remember, the entire of the right lung is coated by the visceral pleura, so I'll show this in blue here, which comes all the way around the lung, like so, and then it folds back at the lung hilum where the right bronchus enters, like so, to form the parietal pleura, like this. And then there's a space in between the visceral pleura and the parietal pleura, which is the pleural space, which is full of fluid called the pleural fluid. So let me just put some labels on here. So the one that's actually surrounding the lung is called the visceral pleura. The one that we get by folding the pleura back on itself, this is called the parietal pleura. So this is the parietal pleura. And then the space in between is the pleural space. And in that space we have pleural fluid. So these are the layers of connective tissue surrounding the lungs. Now, these layers of connective tissue then are innervated by pain neurons, unlike the actual lung tissue. So it's just like the brain. So, if you're going to get pain because of something happening in the lungs, it has to affect the pleura. Now, if you can imagine, if we have a great section of the lung, let's say this great section is inflamed, so you've got inflammation occurring in this great section, this is the place where the pneumonia is occurring, you can imagine that you're going to be producing a huge amount of prostaglandin E2 in all of this tissue. Now, it won't be affecting any neurons that are actually in the lungs because there are no pain neurons actually in the lungs. But some of that prostaglandin E2 will diffuse away sometimes. If this is big enough, if the pneumonia is big enough, some of the prostaglandin E2 will diffuse over to the pleura. So here comes the prostaglandin E2 diffusing to the actual covering that coats the lung, and there it will activate the nociceptors on the ends of the primary nociceptive afferents. And why does the chest pain occur when you breathe? Well, again, just like the pain was there with the barking cough, when you breathe, what happens is you're going to be having the pleura rubbing up against one another. So when the diaphragm comes down and the lung expands, the pleural coverings are going to be rubbing against one another. So the visceral pleura will rub against the parietal pleura. Now, that does not normally trigger pain. It will be activating some little receptors on the nociceptors. And I think just so that I've got something to point as, I will draw a nociceptor in here. So here's the tree drawn quite badly. And then here in white, this can be the peripheral process of the primary nociceptive afferent. So here we have a pain neuron with the nociceptor on its end. So normally, when we breathe in and out, and the lung is expanding and de-expanding, going back to its original size, that movement will be activating some receptors in the nociceptor. However, normally that activation is not enough to make this fire action potentials, and therefore you don't get any sensation of pain. However, when you've got prostaglandin E2 and the movement together, that is enough stimulation of these nociceptors to trigger action potentials to fire. So what will happen is action potentials will fire up here, and that will be sent to the central nervous system, and that will give the sensation of pain in the chest when breathing. And this is what is meant by pleuritic chest pain. So the reason it's called pleuritic is obviously referring to the pleura, because it is coming from pleura. But in reality, clinically, pleuritic chest pain, it doesn't mean pain coming from the pleura. Although the pain is coming from the pleura, we use it to mean pain specifically when you are breathing. So that's the other major symptom that people can get with pneumonia, that when they breathe, it's horrendously painful. So in and out, and you get horrendous pain when that happens. Okay, so those are the two symptoms of pneumonia. As I say, if you have a small pneumonia, you won't necessarily get pleuritic chest pain. It depends on the prostaglandin E2 getting to the pleura and affecting the pleura. So the position of the pneumonia and the size of the pneumonia is obviously extremely important in determining whether you get pleuritic chest pain. Okay, so those are the symptoms of pneumonia. Let's now talk about the types of pneumonia that you can actually get then following influenza. So there are two types. You can, although it's very rare, get primary influenza viral pneumonia. So let's now do these here. So number one, this is the one that's obvious that you could be able to get, but it's actually the rarer of the two. So this is primary influenza viral pneumonia. So we have talked about the fact that all three of the influenza virus species are capable of infecting the alveolar epithelial cells, so the type 1 and type 2 pneumocytes, if they can get down that far. Now, usually in most people, they do not get that far down the respiratory tract. However, if the immune response is weak, then you don't eliminate the virus quick enough, and it will spread down the airways to smaller and smaller airways until it actually gets to the lung parenchyma. So we'll go back to our picture over here. Remember, the virus is making its way down as the disease progresses, and then it's halted in its progression, usually when it's just about got into the early bronchi, by the adaptive immune response. The adaptive immune response kicks in and says, no, you're not going any further, you're dying, and it destroys it. And therefore, the virus doesn't get any further, it doesn't get into the tiny airways, and it doesn't get into the alveoli. If that does not happen for some reason, then the virus will progress further and it can get into the alveoli, and then you will have a lung parenchymal infection, you'll get inflammation, you'll get pneumonia. And that's what primary viral pneumonia is, primary influenza viral pneumonia. Now, as I say, it's really rare. It is very rare for influenza to progress to the primary influenza viral pneumonia, but it means that you will be extremely sick. And this is, pneumonia is deadly. You can't breathe, and if that not being able to breathe gets bad enough, then you will die because of too little oxygen in your blood and too much carbon dioxide within your blood. So it is a very, very serious illness, but thankfully primary influenza viral pneumonia is pretty rare. So let's now go on to the second type of pneumonia that can follow influenza viral infection, which is more common than primary influenza viral pneumonia. So type 2 is secondary bacterial pneumonia. So the reason we call it secondary is you get another infection on top of the influenza infection. So it's a second infection, and the culprit are bacteria. So secondary bacterial pneumonia. Now, normally when people get pneumonia, whether they've got it secondary to influenza or not, usually it is of bacterial origin. I mean, there are other bugs that can cause it, for instance, viruses such as influenza viruses, and of course fungi can actually cause pneumonia as well, very, very rarely. Classically, in people with HIV/AIDS, get pneumocystis pneumonia and aspergillus pneumonia and horrible things like that. You can also get certain types of parasitic pneumonias, but they're very, very rare. So the major pathogen that causes pneumonia is bacteria. So what is going to happen in secondary bacterial pneumonia? So when you get influenza, as I've told you previously, it is horrible, horrible for the respiratory epithelial cells. Loads of them are going to die. Now that means that once you've had this infection, your epithelium is awful. I was about to swear then, but I refrained because this is YouTube. Your epithelium is not very good. It's not doing its job of protecting the body and forming a nice barrier to the rest of the body. So, the idea is then that once you've had influenza, because the respiratory epithelium is so damaged and you've lost so many of the ciliated columnar epithelial cells from that, that it's now much, much easier for bacteria to take hold. So let me just actually draw a little picture of this. So, we'll again need a basement membrane here. So the red comes back again, thick red pen. So here's the basement membrane. Now normally, of course, if we're drawing a respiratory epithelium, we'd have lots of ciliated columnar epithelial cells covering this basement membrane. But after an influenza virus infection, it may well look like this. Maybe you've got one surviving ciliated columnar epithelial cell there. Here it is, with its nucleus. Maybe you've got a basal cell over here which will have the job in the moment of repopulating the ciliated columnar epithelial cell population. But look, we've now got a great big gap here, and that means that bacteria can take hold much easier, because remember, the normal thing that protects the respiratory epithelium from pathogens is the mucus. The mucus that is normally on the surface of the ciliated columnar cells. I'll put a bit on here. That is normally what protects the respiratory epithelium. Normally, we're breathing in pathogens all the time is the reality. And the reason we're not continuously getting ill is they get stuck in the mucus, thankfully, and then they're cleared away. So if you do breathe in a bacterial cell, usually what happens, going back to this picture over here, if you normally breathe in a bacterial cell, either it will get stuck in the mucus lining the nasal cavity, or if it does somehow make its way down into the airways, it will get stuck in the mucus lining the airways, and then the mucus escalator will bring it back up, and it will go down to the stomach and burn and burn and burn. That's normally what happens to bacteria. Now, if you've just had influenza and you breathe in a bacterium, it might not get stuck in the nasal cavity because there's not that much mucus lining the nasal cavity at the moment, because all the epithelial cells are dead and gone. Again, it will make its way down here, and it might just get into one of these airways then now. And normally, as I say, it would get stuck in the mucus of this airway, but now it's got free rule of the place, basically. It just goes straight here, and then it will come to the basement membrane, and then it can start dividing here. It does not get stuck in mucus because there's no cells with the mucus on anymore. So let's put this in here. So I'll have it in purple. So this can represent a little bacterial cell here. So this is a bacterium. And now the idea is that because of the damage to the epithelium, it can take hold here. It can start dividing and dividing and dividing. So I'll show it dividing and dividing and dividing. And it's on the airway epithelium at the moment. But unlike the influenza virus, which was limited to the epithelial cells, bacterial cells know no limits. They will just divide and divide and divide and infect whatever is next to them. So they will now work their way through the wall of the airway. So there are lots of other layers underneath here. There's a big connective tissue there. There will be smooth muscle cells surrounding the bronchial smooth muscle cells. These bacterial cells will just work their way through those. They'll divide and divide and divide and work their way through those. And eventually they will escape the airway wall, and then they will be in the lung parenchyma. So outside of the airway wall is where all the alveoli will be, and then they can spread into the lung parenchyma then, and then you've got a bacterial infection in the lung parenchyma. You'll get inflammation in response to that, more inflammation, and therefore you end up with pneumonia. So, let me just stress again, summarise again the mechanism by which we believe you get secondary bacterial pneumonia in influenza. And again, you have to have quite a weak innate immune response and other immune responses for this to occur, because, you know, if this epithelium had the influenza infection, then the inflammatory response would already be occurring here. So there would be loads of white blood cells, hopefully. So they should be phagocytosing these bacterial cells, so the bacterium shouldn't be able to take hold here. So you do need to have a weak immune response, basically, in order for this to occur, which is why it classically occurs in people who are immunosuppressed for some reason. Okay, so what's going to happen then? The bacteria will be breathed in, and we're breathing in bacteria all the time. Usually we're protected by the mucociliary escalator, but now that's broken because of all the lost epithelial cells, so they will be able to just go and get access to the basement membrane of the airway, and from there they will be able to start dividing, and they will spread downwards through the wall of the airway, and eventually they will make their way out the other side of the airway. They'll break through the airway, and then they'll be in the lung parenchyma, and then they can cause an infection of the lung parenchyma. They can spread from alveolus to alveolus to alveolus, and you'll get inflammation wherever they go, so you'll get massive pneumonia. So that's what happens in secondary bacterial pneumonia, or that's what we believe happens in secondary bacterial pneumonia. And so, the final little thing to say about secondary bacterial pneumonia is which bacteria are generally the culprits in secondary bacterial pneumonia, secondary to influenza virus, because it's not, well, two of them are the normal culprits for bacterial pneumonia, but there's one that is not a normal culprit for bacterial pneumonia, but is a major culprit in secondary bacterial pneumonia to influenza. So let's just mention these. So I'm going to mention 3 different species then of bacterium that are the major culprits of secondary bacterial pneumonia to influenza. So the most famous one, firstly, Streptococcus Pneumoniae. This is the most common cause of pneumonia, full stop. I think it's something like 50% of bacterial pneumonias will be Streptococcus pneumoniae origin. And most pneumonias are bacterial pneumonias. So most pneumonias, therefore, are going to be Streptococcus pneumoniae pneumonias. This is such a common cause of pneumonia that it's given this name, Streptococcus pneumoniae, and it's actually given even a more suggestive name. It's given the name pneumococcus. So when you hear people referring to pneumococci, this means Streptococcus pneumoniae species of bacterium. So, just a few little facts then about Streptococcus pneumoniae. Let's draw a little picture of it. So, it's a gram-positive bacterium, so when you stain it using the gram staining process, it shows up blue rather than red. Remember, the gram staining process, it stains cells one of 3 options. Either it doesn't stain them at all, or it stains them blue, or it stains them red. Blue staining bacterial cells are gram-positive, red staining cells are gram-negative cells, and the cells that don't stain at all, we just say they don't stain under the gram stain, so we don't give them a gram stain classification. Okay, so Streptococcus pneumoniae, it's gram-positive, which means I'll draw it in blue. Now, whenever you see coccus in the name of a bacterium, that means that the cell is a round cell rather than a rod-shaped cell. And Streptococcus means that the bacterial cells grow in belt-like arrangements. So if you actually look at a population of Streptococcus pneumoniae under the microscope, what you'll see is something that looks like this. Each one of those little circles is representing a bacterial cell, and you can see that they're growing in a belt-like arrangement. They grow in lines. So whenever a bacterium is of this type, Streptococcus, and there are loads of different Streptococcus species with different second words here. Whenever you have a species of bacterium that is Streptococcus, it means that it's going to be gram-positive, the cells are going to be round, and the cells grow in these great line-like arrangements. And it makes sense why they might grow in this arrangement. I mean, if you imagine that every single one of the cells, when it divides along the same axis, i.e. this axis, and splits into 2 cells like that, then you can imagine how you can form these whole lines of cells in this way. So that's what Streptococcus means, round and grows in a belt, and they're all gram-positive. So Streptococcus pneumoniae, gram-positive, round, grows in belt-like arrangements. So this is my basic picture of Streptococcus pneumoniae, and it is the major cause of bacterial pneumonia, and it is the major cause still of secondary bacterial pneumonia after influenza. Now, the next one that I want to talk about then is Staphylococcus aureus, a very famous bacterium, however, not a normal cause of bacterial pneumonia. Normally, when people get bacterial pneumonia, it is not caused by Staphylococcus aureus. It can occasionally be caused by Staphylococcus aureus, but it is not a common cause of bacterial pneumonia. However, when you look just at the subset of bacterial pneumonias that are secondary bacterial pneumonias to influenza, it actually is a huge fraction of them. After Strep pneumoniae, it's the second most common bacterium to infect people and cause secondary bacterial pneumonia, secondary to influenza. So it's important for us to discuss it here, but curiously, it doesn't normally cause pneumonia. It's very rare for someone who hasn't previously had influenza in the past week to then get a bacterial pneumonia caused by Staphylococcus aureus. So it doesn't usually produce primary bacterial pneumonia, whereas Streptococcus pneumoniae is the major cause of primary bacterial pneumonia. Okay, so let's draw a picture of Staphylococcus aureus. Staphylococcus aureus is also gram-positive. Coccus means that it's a round cell. Staphylococcus, staphylos in some old language, I think it's Greek, means grapes. So the cells are arranged in grape-like shapes for Staphylococcus aureus. So just drawing this on, here we go. You have like a bunch of grapes here of bacterial cells of the Staphylococcus aureus species. Here we are. And the aureus refers to gold. Clearly, here the pneumoniae was referring to the fact that this bacterium is the major cause of primary bacterial pneumonia. The aureus refers to gold, and this is because when you grow Staphylococcus aureus on agar gel plates, you end up with these little gold dots, which are where all the bacteria are growing. So where the bacteria grow, they produce like a gold colour on the agar plate, and hence this is Staphylococcus aureus. So, there's the picture of Staphylococcus aureus. It's the second most common cause of secondary bacterial pneumonia, secondary to influenza. Okay, and then the final one that I'm going to mention that is a common cause of secondary bacterial pneumonia, secondary to influenza, is another common cause of primary bacterial pneumonia. Not as common as Streptococcus pneumoniae, but still quite common. And this is Haemophilus Influenzae. And I believe the reason this bacterium is called Haemophilus influenzae is it can produce a similar illness to influenza. So Haemophilus influenzae. It's either that or it's that it was originally thought to be the culprit of influenza before we then discovered influenza virus. I can't remember which of those is true. I think actually it might be the second one, that it was originally thought to be the culprit of influenza, and then we discovered no, it's not, it's influenza virus. Okay, so never mind what the truth of that matter is. Haemophilus influenzae, it's another major cause of primary bacterial pneumonia. So not nearly as many cases as Streptococcus pneumoniae. I think it's something like 10 to 15% of cases of primary bacterial pneumonia will be of Haemophilus influenzae origin. So, but it is a major cause, and it is also a major cause of secondary bacterial pneumonia, secondary to influenza. So, Haemophilus influenzae, it's a gram-negative rod bacterium, so it's different to the other two. It's going to stain red with the gram staining process, and it's no longer a round cell, it's a rod-shaped cell. So, it's a rod, it's gram-negative, and it is a major cause of bacterial pneumonia. Okay, so there's my brief picture of Haemophilus influenzae. So these are the three main culprits of secondary bacterial pneumonia secondary to influenza. Streptococcus pneumoniae, also called pneumococcus, Staphylococcus aureus, and Haemophilus influenzae. Okay, excellent. So we've now discussed pneumonia, severe complication of influenza infection, and this is why people die of influenza infection. When someone dies from flu, what will have happened is they will have got pneumonia, which will have then led to respiratory failure, them no longer getting enough oxygen into their blood and taking enough carbon dioxide out of their blood to actually survive. And so I might just write down that key term. So if you get short enough of breath, i.e. your respiratory system doesn't perform its role enough, then what you get is called respiratory failure. The respiratory system is failing the rest of the body. It's failing to do what it's meant to do, which is exchange gas. And this can be fatal. And this is normally the way that people die from influenza, by getting pneumonia, which then leads to respiratory failure. And it's far more common that people get secondary bacterial pneumonia rather than primary influenza viral pneumonia, but this can occur. Okay, so that's pneumonia. The final thing that I want to discuss in this video before we have a break and then in the next video we move on to the adaptive immune response is just make a brief comment about colds. We'll come back to the symptoms, I think, because we started the video by discussing the difference between a flu and a cold. Let's, now that we know much more about flu, talk more a little bit about colds. So colds are also a local respiratory tract infection that is caused by viruses, but they are caused by different viruses to the influenza viruses. They are caused by usually viruses that are called rhinoviruses, spelt like so, rhinoviruses, or coronaviruses. These are the two main types of viruses that cause colds. And these viruses infect the exact same cells as the influenza viruses. They infect the respiratory epithelial cells, and they go into the cell, exploit the cell, and thousands of virus particles come out. The difference between cold viruses and influenza viruses is that these ones are much less likely to kill the cell than influenza viruses. So influenza viruses, they're much worse for killing the respiratory epithelial cells compared to the cold viruses. And this is the reason that you get much less inflammation in response to a rhinovirus or a coronavirus infection compared to an influenza virus infection. So, just to stress this point, these cells can infect the exact same epithelium as the influenza viruses. Again, they cannot infect the non-keratinized squamous stratified epithelium, so these little areas, the oral cavity, the bottom portion of the nasopharynx, the oropharynx, the laryngopharynx, the top portion of the larynx and the esophagus, they're all safe from cold viruses as well as influenza viruses. But these will infect the nasal cavity, the nasopharynx, the bottom portion of the larynx, the trachea, and they'll go down into the early bronchi, just like influenza did. But they don't cause as much damage to the epithelial cells as influenza virus did, and therefore you don't get as much inflammation. So, with a cold, you will get similar symptoms. The local symptoms will be the same because you're going to get inflammation in the nasal cavity producing these symptoms, inflammation in the pharynx and larynx producing this symptom, inflammation in the larynx producing a hoarse voice, and then inflammation in the larynx, trachea, and bronchi causing coughing to try and clear the phlegm, and maybe a bit of shortness of breath because of the bronchoconstriction of the bronchial smooth muscle cells down in the early airways. And again, it should not get any further than the early airways because the adaptive immune response will kick in and bust it out. However, if you are extremely immunosuppressed, these can go down to the alveolar epithelium and they can infect the alveolar epithelial cells just like influenza virus can. So amazingly, and you might not believe it, but it is true, colds can cause viral pneumonia. And this is why everyone says HIV, AIDS is such a terrible illness, because you can then end up dying of a cold. When you're extremely immunosuppressed, colds can kill you because they can cause primary viral pneumonia, or they can cause secondary bacterial pneumonia, as we've discussed with influenza virus infection. Now, again, I'll stress the difference between flu and cold for most people, so we're not talking about immunosuppressed people now, we're going back to most people, is that because you get much less inflammation in the airways with a cold, you're not going to get as much TNF-alpha and interleukin-1 and interleukin-6 going into the bloodstream, and therefore the systemic symptoms are nowhere near as bad in a cold compared to flu, and therefore usually you don't become extremely tired, you don't get the fever nearly as bad, you hopefully won't get chills and shivering and rigors, and you hopefully won't get appetite loss, and hopefully not the headache and the muscle aches. You might get these to a tiny degree, but you don't get them anywhere near as debilitating as you would with flu. And therefore, as I said at the beginning, if you've got the respiratory symptoms but you feel okay and you feel as though you can go to work, it's a cold. If you've got these respiratory symptoms and you feel absolutely like you're dying, then it is flu. Okay, so that is a little bit more of a discussion about the difference between a cold and flu. Fundamentally, both of them cause upper respiratory tract infections and lower respiratory tract infections. They both infect the lower respiratory tract as well as the upper respiratory tract. But because the cold viruses don't do as much damage to the epithelial cells, they don't kill the epithelial cells nearly as easily as the influenza viruses do. You don't get nearly as much inflammation in the respiratory epithelium, and therefore you don't get the systemic symptoms in the same way as you do with flu. Okay, so we will have a break here. In the next video, we will discuss the adaptive immune response to influenza viruses, which of course is extremely important because it's the way we're going to fight these things off. It's also the way that you would fight cold viruses off, but we're going to abandon talking about cold viruses now. We're going to just concentrate on the influenza viruses. And it will be a good opportunity for us to revise immunology, which of course is so important. Okay, so see you in the next video.